Okay, so let's get started. So my name is Noelle Sio. I'm a principal data scientist at Pivotal. So what we do at Pivotal is help other companies realize their vision with big data. And so what we see as the data science team is a lot of companies who have a vision for what they want to do and understand that big data is a part of it and need help from end to end. And so what I've been asked to speak to you about today is specifically about smart cities. So we see a lot of things around across different industries that affect this, and wanted to give you a quick introduction to what, from the data scientist perspective, is kind of future smart cities, and specifically how data science plays a role in that. So when we wanted to define what is a smart city, I think of two different things. And this is probably something similar you've heard through the past couple days as it relates to things like smart homes, all the various technologies. People, processes, and things are all connected to the internet. This is actually a map of the internet, something that starts to look like a network, starts to look like a brain. All of those things are connected. And when you think of the things that exist in a city, you can start thinking about all those things are gathering data, all those things that are connected. So there's us, there's the people, all of the smart devices that we have, things that we do every day are all feeding in data. We talked a lot about this the past couple of days. There are the processes. So when you think about services, things in a city, things like getting a license, for instance, all of those things are also connected. It's not just a manual process anymore. And the things themselves, cars, streets, traffic lights, stores, are now, you consider them inanimate objects, but are also now part of this vast system. And the second point, so it's not just enough to be connected. These things are smart for a reason. They learn. So it's not just about what it can do right now, what the intelligence is right now. It's also that it's constantly evolving and constantly learning. I promise I really am good with technology. Okay, so when we start thinking about this, there's I start with the data. We always start with the data. Right? There's two types when I start thinking about all of the things that are available for cities to consider. And one is that data has already existed for hundreds of years. It really has. When you start thinking about the census, it's one of the go-to sources of data that we use now, something that's available for many cities across the world about the people and what people are doing and basic statistics. This is not a new concept. This has been around for hundreds of years. If you want to go back to several hundred years ago, go to the right library, look at a census from a specific city, figure out, they'll give you access to the really old pieces of paper. This data exists. You can go get it, but it's really hard to get single points of data. What we're talking about now is that it's instrumented digitally. And now you can start looking at that. It's available at your fingertips. It's available for the data scientists, for people to look at. So just give some examples. You can look at the census online. You can download the data. It's freely available. And we're starting to see that making data available online is actually causing a lot of disruption, in a good way, with innovation. So we're starting to see this not only by things that are available through the census. We see this for education. Education for countries like ours that are trying to radically change what we do, starting to look at all of the data that we have and understand, is there something we can do to make this better? There's also things related to transportation itself. As you say, we have stuff from the motor vehicle organizations, we have things from the police, trying to understand crime. Again, these are all things that before were siloed, or they weren't data-driven, but have the possibility to be data-driven now. There's possibilities for innovation for all of these things. So in addition to having all the old sources of data that are now making the transition from being purely on pieces of paper or in some filing cabinets going digital, we have new sets of data that are coming in as well. And again, these are all things that I think you've heard in the past couple days. Can you put a sensor on that? Sensors, I know it's an overhyped word when we talk about the sensor net or the Internet of Things, but that's really what's leading or enabling all the innovation that we have. So here's a quick example. Again, I think these are all things that you've heard over the past couple days, that we now have telematics. We have telematics in cars. Did you know that if your car, if it's a model after 1997, has telematics data that you yourself can go get and just plug it into the dashboard? We've talked about smart meters. Like everything in our homes is now starting to collect data. We're starting to be able to understand it. And this has helped disrupt the utility sector, the energy sector. How can we start using that to to prevent things like blackouts? Traffic lights now have data. We can start understanding how, when trying to predict when lights turn red or when they turn green, and how we can start to do more about urban planning. And ultimately, so there's just a few examples, but pretty much anything that you think you can put a sensor on, it might be interesting, you probably pretty much can now. Right? I think we had a bunch of talks about iBeacons specifically. That's going to really change how we do analysis and how we look at the world and what innovations will come in the next several years. So then what about data science? Where does data science play a role in this? I always say that there's no contest for getting the most data. You don't get a prize for having the most data. You really don't. Although it may seem like that. You only get an advantage for collecting all of this data if you do something with it. And that's where data science is. As I said, we've been collecting data for hundreds of years, but it's only been in the past 10 years or so, I think, since the emergence of petabyte-sized data, as well as cheap storage, that data science has really come into its own. Right? So when I think of data science, because I come from a digital media background, right, like all of this innovation came about because we were trying to get people to click on ads, because that's what fueled the digital media industry. All of those learnings have helped us disrupt multiple industries, as multiple industries are now starting to also get new data and big data and also adopt the technology. Everything is shifting. We can see this in finance, we can see this in healthcare, we can see this in pretty much everything. And so when you think about it, though, taking a step back about our cities, how is understanding what people are going to want for services for any consumer business any different than for a city that wants to know how can it optimize its services, right? Like if the things that it wants to provide for its citizens, how can you make the experience of some consumer product better? It's no different than how you can make the experience of living in a city better. All of these things can be applied to the cities of today and tomorrow. So what I want to do is just walk you through a few examples of things that we started to look at and that help create the vision for what the smarter cities are. So as I said, each and every one of you has something that you can plug into your own car to get telematics data. Some of my colleagues built a demo, taking the data from their cars, actually, saying like, what can we do with this? Right? We have data. Well, all of us have cars, so let's take the data. So we now have the data source. We are our data source. Collected the data, streamed it into a platform, did some predictive analytics on it to say, okay, now that we understand all of this stuff gathered from the car, can I predict where I'm going next? And if I can predict where I'm going next, then I predict how much fuel I will need to get there, and what's the range of the fuel that's left in my tank? And can I do this in real time? Can I do this? And so we went down this experiment, and we were able to actually do this. What you see on the right is actually a snapshot of the app. So in real time, you can start, as you're driving your car and you have the app open, you can actually start to, look at the statistics immediately, which is the first step for doing any of these things, is having access to the data. And then secondly, the prediction, what's going to happen next. And so other than being a really interesting app, because as a data scientist, I think this stuff is really interesting, it's also something that can be fed back into urban planning. It could be understand where's everybody going. If you understand where people are going, you can also start thinking of the applications. You can understand where to put a petrol station. You can understand where traffic jams are going to occur, and maybe there's something that you can do about it. Speaking of traffic, taking one step back, not just the individuals who have the data, but our cities themselves who have data. Right, so we have things such as Transport for London, and then Weather Underground makes their data open. So Traffic for London has a data feed where it tells you every single traffic disruption that's happening in London. So it'll be able to tell you like, hey, there's a burst water main. Over here, it will tell you that there is a collision that happened, and it updates this feed every few minutes or so. And so one of the things that we realized with this data feed is maybe what can we do with that? Like, it's one thing that it's reporting in, that's great that we have data. Can we do prediction? And that's what data science questions are about, really. Like, what can we predict next? Can we do something about it? And the answer, as you see here again, an application that we have made was to say, okay, I can tell you how much time is left. I know where it is, I know what the weather is like, I know what type of collision it is and how long it's been going for. I can give you a fairly accurate estimate about how much time is remaining. Right? And so we're able to feed that, again, back into an app that we can put in the hands of people. And that could be used if, for instance, you're have a fleet of cars and you want to know, it's not just to look up a map, but you want to know, okay, when can I send someone here or there because the traffic jam is going to be back, or traffic jam will clear up rather. And ultimately you're able to do lots of things with open data and things that you could, that are available to everyone. And so if you're actually curious, actually see this online, you can actually go to that URL and see in real time what the traffic is happening in London. And finally, to abstract this up with one more step, I know that I've been talking about use cases that are very technology heavy. Right? Like we already think that cars and traffic, we already know that those things are very, have applications for data science. And so one of the big things that we hear in the automotive industry right now is predictive maintenance. We all want to know when we want to know when a car part will fail. And in technology, we want to know when a server will fail. We're always trying to predict when these things happen because these things are costly. The project I'm going to tell you about now is actually doing predictive maintenance for trees. So the Department of Parks and Recreation in New York City had partnered with DataKind. Has anybody heard of DataKind? Okay, good. All right, so they had a project there that they partnered with them to ask. So it's a nonprofit organization, by the way, that hooks up data scientists with nonprofits who we've realized also need predictive analytics. It's not just the technology, the big tech guys. And so they wanted to know, can they predict when they need to maintain the trees so this doesn't happen, right? When something like a huge, well, first of all, that's bad. That's a bad day for that poor car, unfortunately. But not only is it a bad day for that poor car, but it's also very costly for the city, right? It's not only going to be cleaning up that poor tree off that street, but also the traffic around it and all the implications for the city around it itself. So they wanted to know, like, could they how do you prevent that from happening? Right? And so they were able to take data, again, data that you don't think about coming from the industry, but data that does exist about planting schedules and trees and the maintenance records for those trees, and realize that they could actually cut down the likelihood of things like this happening if they updated the schedule of pruning. Right? They could say, like, rather than being every 15 years, if we do this every 5 to 10 years and invest that money, our return on investment is that we could avoid giant trees falling on people because the trees will never get quite that big. Right? And that's worth the risk for them. And so if you imagine that this kind of innovation is great, right, and it's applicable upon all these things, so the next question is, where is this possible? And the truth of the matter is, if you do a little digging, it's actually available worldwide. The government is opening up data across the world. So if you actually look at something like datacatalogs.com, it'll actually show you that a map with all sorts of data sources that are available. And so there's ones that, like, I'm very well aware of, things like data.gov and the Open Data Institute and the European Union for Open Data Portal. Again, like, all of these things are available to us, right? We all live in one thing together, and so ultimately we have the power to change with data science and open data. That's step one. So this makes me very excited that that this is kind of a phenomenon that's happening. And with that, that's it. Any questions? All right. That's fine. It's at the end of the day. Everyone have a great day. You can come find me if you have any questions. Thank you very much for your time.